Hello everybody, my name is John Armstrong and I'm the director of the Ott Planetarium at Weber State University in Ogden, Utah. And today we're going to talk about finding things in the night sky. So let's go ahead and get started. Right now I'm looking to the north here in Ogden, Utah, and I want to start by identifying some simple constellations that I think we all can recognize. Looking to the north, you'll see the Big Dipper right here. And the Big Dipper is a constellation that most of us in the Northern Hemisphere are familiar with. It's got its handle here and it's got its little cup. And because we can all agree that that constellation is called the Big Dipper, when I tell you to look in the sky at the Big Dipper, you look to the north and you see that pattern of stars. That pattern of stars also points us to probably the most important star for finding ourselves in the night sky, which is the North Star. So if I go down the handle here and look at the cup, and then I follow these 2 points down, that next brightest star is the North Star, also known as Polaris. And once you've found Polaris, you have now found the direction of north. So the constellations, because they're an agreed upon collection of stars, allow us to orient ourselves, but then once we find the North Star, we can start to use more specific coordinate systems. In particular, I can look at how far off the horizon the North Star happens to be, something we called its altitude. I can measure angles on the sky using my fist. If I hold my fist out, extend my arm fully, that's about 10 degrees on the sky, and if I count how many times I can stack my fists up to the North Star, that's going to give me a measure of my latitude here on the planet Earth. So if I do that in Ogden, Utah, I get about 4 fists and a little bit, so about 42 degrees is my latitude in Ogden, Utah. And that tells me what the altitude of the North Star is. The North Star is 42 degrees off the horizon, and that tells me its altitude. And our horizon system has another coordinate called the azimuth. So we have the altitude off the horizon, and then we have the azimuth. So I have north is 0, east is 90 degrees, south is 180 degrees, west is 270 degrees, and then we come back to 360 degrees or 0 in north. So that's the azimuth. So the azimuth of the North Star is 0, and its altitude here in Ogden, Utah is 42 degrees. So that allows me to be able to find where things are in the night sky without necessarily knowing what the constellations are. For example, the Big Dipper, if someone didn't know what the Big Dipper looked like, I could say, well, look to the northwest and it's about 35 degrees off the horizon. We'll show you the cup of the Big Dipper. So that allows us to be very specific about where things are in the night sky, and we don't necessarily need to know the names of the constellations in order to do that. Now, the only problem with the horizon coordinate system is that it's only relevant to people who happen to be with you at your location. And look at the North Star, that's 42 degrees off of the horizon for me in Ogden, Utah. If I happen to be located, say, at the North Pole, that would be directly overhead at my zenith. And if I happen to be at the equator, that would be located exactly on the horizon, 0 degrees of altitude at the equator. So clearly the horizon coordinate system doesn't work. What does work is a coordinate system relative to the North Star itself. So if somebody can find the North Star in the sky, if they had a coordinate system based on that, they could find everything else that you were telling them about. So that's called the equatorial coordinate system, and it's called the equatorial coordinate system because it's based on the same types of coordinates that we use on the Earth for latitude and longitude, and that is based on the North Pole and the equator. So I'm going to go ahead and just put up what that equatorial grid looks like, and you can see that it culminates right on the North Star there. So the North Star is always at the same point for everybody on the equatorial coordinate system, and this coordinate system has a line on it representing the equator. So this is 0 degrees of 0 degrees on our equatorial coordinate system, and that represents the equator. Now we measure from the equator to the North Star in terms of declination, which is similar to latitude on the Earth. We call it declination. And then we measure across the sky in something called right ascension, which is similar to longitude on the Earth. And you'll see those terms as you get more familiar with astronomy. But the right ascension and declination is a coordinate system that you can use to communicate with other people on the planet, because those coordinates are going to be the same regardless of location. So that gives you 3 ways of finding things in the night sky. First, by identifying constellations. If we all agree on what those constellations happen to be called, we can identify where things are in the night sky. The horizon system, which allows you to be very specific to people who happen to be near you, showing them where things are in the night sky relative to azimuth, and altitude. And then finally we have the equatorial coordinate system, which gives us the same coordinates for everybody on the planet in terms of right ascension and declination. And so those are 3 ways that you can find things in the night sky. This is John Armstrong from the Planetarium, signing out.